Okay, this is question 23 of the trial stats paper. This is a correlation question where you will have to enter the data into the calculator as well, so you can draw your scatter plot and line of best fit and find Pearson's correlation coefficient. So you've given the information in a table. Notice there's only 10 or 11 numbers, so it's not going to take you a long time to enter in there. This is the y, this is x. So x and y, sorry, the first one's x, second one's y. So this is always list 1. The first one is always list 1. Make that list 1 and make this one list 2. So on your calculator you'll need to come back into stats, so you're back into this bit here and you go straight into your lists. Now I've entered the data into list 2, but there's data from other questions in list 1. So what you'll have to do, whoops, daisies, you'll have to go to, you might have this window here, so F6 will get you to delete all, and we're going to delete all in list 1. So if you hit F4, it says, do you want to delete all the list? Well, yes we do. Go F1 and it takes them all out there. Now we have to enter in these numbers into here. So we go 0, then 1, 2, 3, 5, 6, 7, 9 and 10. Very good. And that's all sitting in there now. Determine and describe the relationship between the concentration of the new chemical and the percentage of infected vegetables. So this is putting concentration of chemicals and seeing how much is being infected. So hopefully what's going to happen is the more chemicals we put on there, the less infections we have. And we want to find out the Pearson's correlation coefficient and the coefficient of determination. Another way of saying that is this is the R squared version. Okay, the coefficient of determination is the R squared one, which gets rid of the negative or positive slope. So let's have a look. How do we do that? Okay, what you do now, you've got the data in your calculator. Now we want to draw the graph of it. So come to F1 and do the graph, and we want to check that it's all set up properly. So if we go set, we want to have a scatter graph, and we just want one graph which is using list 1 and list 2 in our scatter graph. That's cool, so that's just stat graph 1, that's exactly what we want. Select, we only want to draw on stat graph 1 because that uses the data from list 1 and list 2, and that's pretty cool. And if we go draw now, we'll get a scatter plot, and you can see there's a fairly good correlation there. It looks like there's a bit of an outlier out here. Let's have a look to see what happens. We then come to calc, which is F1, go to the X, which is F2, and it gives us all the things we need to do. This one here is your Pearson's correlation coefficient, which is minus 0.34. So it's minus 0.34 across here. And then the R squared is the coefficient of determination, and that gives us 0.11. So it gets rid of the negative. It's a very weak correlation. There's a decreasing linear relationship because when you look at it, it goes downhill like that, and it's a negative slope. Okay. Is there an outlier in the data? Which one is it? Yes, it's 9 and 6.88, and you can see it's up here. If you wanted to check that, you could go Shift, Trace, and just keep on moving around until you find, there it is there, y equals 6.88 and x equals 9. So it's that piece of data there. So if we remove that outlier, let's see what happens to the correlation. So you've got to come back to here, you've got to find it, you've got to delete it from that list, and then come across and delete it from that list so that the list is still the same. Now we should be able to then draw the graph. Beautiful. See how that outlier's gone? And then go calc, x again, and it gives us a R squared of 0.96 or 0.97 when we round it up, which is a very strong correlation again. So it means that the more chemicals we put in, it's killing all the bugs off, which seems to be pretty good. Okay, now the equation of the line is using A and B, so y equals AX plus B, or in this case, because you're putting in that pesticides, it will probably be P equals minus 0.05C plus 6.6. So that's our equation of the line, and we can now substitute in. You can leave the x's there, I think that's not too bad. You could even say y equals minus 0.05x plus 6.6, because this comes off your graph. Okay, works both ways. Next question says, using the equation of that line, what happens if you've got 5.5 milligrams per litre? So 5.5 milligrams is your X value. Okay, so all we do is our little equation of the line, we replace the X value by 5.5. So our equation is y equals minus 0.05 x plus 6.6. So we are putting in, instead of x, we put in 5.5 because that's what the question tells us. We substitute it into there and we solve it, and it comes out as a percentage, which is 6.3%. Okay, predict the percentage of vegetables affected by the fungus. We think 6.3% are going to be affected if we put that in there. Okay, that is called interpolation, because it's within the data range that we're using. Okay, now a prediction was made, the amount of chemical needed for only 5.7% of the vegetables to be infected. The equation of the least line was used to determine the amount of chemical needed to achieve this level of infection. So we're looking at the 5.7. Now this is your y value, so we need to substitute it in to the equation, or the p value if you're using that way. So remember, our equation is y equals minus 0.05 x plus 6.6. We've now got this bit here. Okay, so that gives us 5.7 equals minus 0.05 c plus 6.6. I'm going to change this to an x so it's a bit easier to work out. So now we've got to do a rearrangement. We want to move this bit here across to here. So if you remember, in the olden days, take your 6.6 from both sides. So it'd be minus 0.05 x equals 5.7 take 6.6. Therefore x equals, so now we're dividing, so it's going to be 5.7 take 6.6 over 0.05, and that's negative 0.05, and you'll get an answer when you do all that kind of working out down there of 18. So that is 18 milligrams per litre is needed to achieve that, according to the least squares regression line, which says that it's not actually the 15.5, it's actually the 18 milligrams. Okay, so it means using that prediction line you can actually get a bit more accurate theoretically about what it's going to be doing. So discuss the reliability of this prediction. The reliability of 15.5 milligrams is not that reliable because you require 18 milligrams per litre, not 15.5 milligrams per litre, according to the least squares regression line. Okay, so you've actually solved it there with doing that. So it's not reliable according to the least squares regression line. Cool. And that's the last part of the stats paper. So those kind of things you may find in the exam.